Good morning everybody. So sorry for the network issue. It's not from our side, actually it's from the modem people, and now it's been rectified. And today we are going to start the chapter simple harmonic motion, and today only we will complete the chapter also, don't worry. And by this chapter our 11th topics are coming to an end. Okay, so please pay attention properly, because these topics have applications in like electrostatics and all, because you remember like a charge oscillating, so there and all you have to apply the same concepts. Okay, and coming to this chapter, simple harmonic motion. So we know some difference between like periodic motion, oscillatory motion, like simple harmonic motion. Periodic motion means any motion which will repeat after an amount of time. For example, a planet revolving around the sun. It will repeat after 1 year again, right? So it is a periodic motion, but it is not oscillatory. Oscillatory motion is something like to and fro motion. Okay, oscillatory motion is to and fro motion, and simple harmonic motion is a part of oscillatory motion which is having some specific conditions. Okay, so all SHM are oscillatory motion, all oscillatory motion are periodic motion, but all periodic motion are not oscillatory and SHM. That is the relation. So what does what is the speciality of simple harmonic motion from our oscillatory and periodic motion? Simple harmonic motion should be periodic, SHM should be a periodic motion, it should be oscillatory, and it should also obey one condition, that is force should be proportional to displacement. Okay, so this condition makes simple harmonic motion different from oscillatory and periodic, like all other oscillatory and periodic motion. Okay, so SHM should be periodic, oscillatory, and force proportional to displacement x. This we have already seen, and we have written like F proportional to x, and removing the proportionality we will get F equal to minus kx. Okay, why minus sign is because we are first one is external force, second one is restoring force. Okay, when F is proportional to displacement, it is oscillatory force, external force, and when F is equal to minus kx, negative sign comes because of restoring force. Why? Because as you know, if a pendulum is oscillating, like restoring force is acting towards the center. Okay, so opposite to the direction of motion. That is the significance of negative sign. But sometimes when we take the magnitude, we don't have to consider the negative sign. Okay, we just focus on the magnitude. So what is it? Negative sign is because it is directed towards the main position. Force will be always directed towards the main position, which will be opposite to the direction of motion. Okay, that's why it is negative sign. Is that clear? Please repeat from first. Okay, periodic, oscillatory, SHM. All SHM are oscillatory motion. All oscillatory are not periodic. Okay, all oscillatory motion and SHM are periodic motion, but all periodic motion are not oscillatory. For example of periodic but not oscillatory is planets revolving around sun. Okay, oscillatory and periodic are like simple pendulum and all. If it has to be SHM, it have to satisfy this condition also, F proportional to x. When we write like this, this is external force like mg sin theta and all. Okay, and not mg sin theta, like if I am pulling it, I am the one who is doing the applying the force, that is external force. This is restoring force. Okay, restoring force will be always directed towards the mean position, which is opposite to the direction of motion. Okay, that's why the negative sign is there. Is that clear? Okay. So from the equation that f equal to minus kx, okay, from this we are doing the derivation, because you know f equal to mass into acceleration, which is equal to minus kx, okay, and acceleration can be written as what? D square x by dt square, okay, from our differentiation. Then this equation becomes m dx square by dt square equal to minus kx. On further modification, we will get this equation as m d square x by dt square plus kx equal to 0. Now if I am dividing the whole equation with m, you will get d square x by dt square plus k by m into x equal to 0. So this is a second order differential equation in x, okay, the variable is x and it is a second order differential equation. Such equation are the, like, this type of equation is called to be equation of SHM. So all SHM have a similar equation. Here we can see that k by m is a constant. So d square x by dt square, the constant we will write as omega square x equal to 0. There is, like, this is how we introduce omega. Omega is angular frequency, which we already knew, but here we are substituting k by m as omega square. So omega will be equal to root k by m in this case, okay. So, repeat what? Which part do you want to repeat? Kanishka? Okay, till here you understood, right? Here we are introducing k by m as a constant. K is constant, mass is constant. So we will replace it, substitute it with omega square. And so omega will be equal to root k by m. Omega is angular frequency, okay, that we already knew. That same omega we are using here, but its value will be root k by m in this case. So any equation which can be satisfied with this formula, okay, such a motion are called as SHM. So this is our basic condition. Other than this, if any motion can be expressed in this equation, such motion are called as simple harmonic motion. Is that clear? Okay, so from this we will get omega equal to root k by m. Till here I hope it's clear for all. Now moving on, we need some further relations also, okay. If we are seeing, we need to find what is velocity, okay, or x. We have to solve for x. When we get a differential equation, what do? We have to solve that equation. But second order differential equation you guys are not solving in 12th, okay. So we will directly take the result, x equal to a sine omega t plus 5. Like this we will assume the solution. A is a constant, omega is same omega, root k by m, phi is phase constant. This is the solution we are assuming, okay. It is not like we are not deriving this. This is a solution we are assuming. But if you substitute it in here, in each place, you will get that this is valid only, okay. So A will be amplitude omega, that we will discuss. Now if x is equal to this, what will be dx by dt? Dx by dt equal to what? We have to differentiate this thing, okay. Upon differentiation, you will get it as a cos omega t plus phi into omega. This will be the differential of dx by dt, and this is our velocity v. Okay, and this cos omega t, can I write it as 1 minus sine square omega t the whole root? So it will become a under root 1 minus sine square omega t plus phi, okay, into omega. Now if I take a inside the square root, it will be a square minus a square sine square omega t. So a square minus x square, that's how we get the formula velocity of SHM equal to root of a square minus x square into omega. Okay, this is the formula for velocity of SHM. Similarly, if you find d square x by dt square, this from here only you will get it as minus omega square x. This will be acceleration of SHM minus omega square x. Is there any doubt? We are assuming the solution for this differential equation. Then on differentiation we will get velocity of the SHM, and from this only we will get acceleration of the SHM. Okay. Other than this, acceleration also have, like if you differentiate this acceleration, you will get this equation also, minus a omega square sine omega t plus phi. This is also an equation for acceleration. Okay. If there is no doubt, we can move on. So here you can see few of the quantities related to simple harmonic. Acceleration we already discussed. Displacement can be written as a sin omega t or a cos omega t. Okay, for same motion we can say in sine terms or cos terms, because both are periodic, only phase will be different. What is phase we will see in the next slide, so don't worry. And this equation also we already got. This plus or minus depend on if it is cos omega or sin omega. Okay, and maximum speed will happen when x equal to 0, right? If I substitute x equal to 0, I will get maximum speed, that is omega a, which means at the mean position maximum velocity will be there. Okay, at extreme position x equal to a, if I substitute that, what will happen? Velocity equal to 0. So at extreme position velocity 0, this end and this end, and in the exactly in the middle mean position velocity is maximum, that is omega a. Acceleration formula like this, as you know, like this is maximum acceleration substituting x equal to a. So maximum acceleration is at extreme points and minimum acceleration is when x equal to 0 at mean position. At extreme position velocity equal to 0. At extreme position acceleration is maximum, at mean position acceleration is 0. Okay, so extreme position velocity 0, acceleration maximum. Mean position velocity maximum, acceleration 0. Now this we will come to later, like for spring mass system and for simple pendulum, what is time period? Time period formula comes to be t equal to 2 pi by omega. So whenever for a system, if you want to find time period, you have to find what is omega in that particular system. Okay, so when you want to find time period, you have to find omega, substitute that, you will get time period. And 1 by time period is equal to frequency also. So if you want to find frequency also, you have to find omega. Is that clear? Okay. Now let's see what is phase of SHM. Phase doesn't mean like any complicated thing. Just imagine there is an oscillation, okay? It is oscillating and you are starting the timer. You have done simple pendulum experiment, right? You will start the timer either at extreme position when you start the oscillation or from the middle when it reach. Okay? If depending on that where you start the timer, our motion will be different. For example, for a particular oscillation, I started from the mean position. It will look like this, okay? If I started the timer at the mean position, means x equal to 0, it will look like this. It will go to high amplitude, then it will come to mean position, then it will go to negative amplitude, and like that. But if I start from extreme position, like you are holding like this, from here I started the timer, means it will look like this, right? So this is the difference between phase. If you are writing this expression, this is sine function, okay? This will be a sine omega t if you are describing this motion. If you are describing this motion, it will be cos function, so a cos omega t. Understood? But if you want to express this in terms of sine, it will be a sine pi by 2 minus omega t, right? This is a sine omega t, just sine graph, that's it. This is a cos omega t, but this one also you can express in terms of sine. In that case, it will be sine pi by 2 minus omega t, because cos omega t equal to sine 90 minus theta. In such a way, we can say that for phase of this one is equal to pi by 2. Okay? Next, for example, this one you want to express in terms of cos. This will be a cos omega t plus pi by 2. Okay? Then in this, pi by 2 is again phase, okay, of the oscillation. Here it is easy to find because it is either at maximum or at minimum. But see here and out, it is starting from this point, okay? It is difficult to find. So instead of writing what exactly is the phase, we will just write a sine omega t plus phi. It can be any value. It is starting from that point. We are starting the timer. Now is the concept of phase clear for all? Phase of an SHM. Okay. Moving on. Then next is energy of SHM. Okay, it is very important topic. Like first part is time period. First important. Next important one is energy of SHM. Okay, first we have to find potential energy. How do we find potential energy? It is negative of work done to bring work done. Okay, it is negative of work done. So we can say it is integral f dot dx. Okay, f is equal to minus kx. So if you substitute that, you will get it as half k x square. Potential energy equal to. Okay, here this is the negative of work done is potential energy. Substitute f equal to minus kx. When you integrate it, you will get potential energy equal to half kx square. Similarly, if you want to find kinetic energy is nothing but half mv square. V equation we already have. What is V? V equal to omega root of a square minus x square. V square if you are taking, it will be 1 by 2 m omega square a square minus x square. This is kinetic energy. Okay, in this if you take omega, okay, omega square is equal to k by m. If you substitute that here, mm will get cancelled. You will get half k a square minus x square. This is kinetic energy. Is that clear? Once you find potential energy and kinetic energy, you can find total energy equal to potential energy plus kinetic energy. When you substitute these values, you will get it as half k a square. This is total energy of the SHM. K is a constant value. Amplitude is a constant value. So, total energy will be constant throughout the motion. Okay, at any point you take, kinetic energy plus potential energy will be equal to total energy. It is a constant value. Okay. Now, if you are saying when x equal to 0, at mean position, potential energy is 0. When you take extreme position, x equal to a, potential energy is maximum and is equal to total energy. Coming to kinetic energy, n x equal to 0, kinetic energy maximum. Kinetic energy maximum at mean position. Why? Because velocity is maximum there. Velocity is 0 at extreme position. So, the extreme position kinetic energy is 0. Is that clear? Based on this, we have to draw a graph. See, now we will come to that later. Okay. This is the graph of like potential energy, kinetic energy and total energy against displacement. Okay. So, what is given here? This is mean position 0. This is maximum amplitude A in positive direction, maximum amplitude A in negative direction. Okay. Kinetic energy is maximum at 0. So, let us say this is equal to half k a square. This is energy. Okay. Here we are plotting energy. Here it is displacement. So, k a square is the maximum value, right? Total energy is this value only. Kinetic energy maximum here. So, at this point kinetic energy is maximum. Extreme points kinetic energy is minimum. So, connecting this you will get this graph. So, this is the curve of kinetic energy. Now, if you want to find potential energy is 0 at mean position, maximum at extreme positions. So, connecting this you will get graph of potential energy. Okay. So, this is the potential energy kinetic energy curve with respect to displacement of SHM. For remembering this, remember potential energy we represent using letter U, right? So, its graph is like U. Kinetic energy opposite of that. So, you can remember that also. You don't have to get confused. Is there any doubt in this? Okay. Other than this, this is graph with respect to displacement. With respect to time also you will get. Okay. So, this is energy versus time. Let's say the particle is starting from mean position. Okay. If it's starting from mean position, kinetic energy is maximum there. Okay. So, if it is starting from mean position, kinetic energy maximum. So, this will be the graph of kinetic energy. Okay, with respect to time. Now, potential energy is 0 there. Energy is not negative. Okay, don't take it like that. Energy is not okay, energy is not negative. Energy versus time. So, kinetic energy you will get like this. 0 at like extreme position and 0 at mean position and again this is kinetic energy. Kinetic energy is 0 at extreme position, maximum at mean position. So, we said that it is starting from mean position. Now, if you are taking potential energy, it will be 0 at the mean position, then maximum at extreme, it will go like this. Blue will be potential energy here. Okay. That is the time versus energy graph if the object is starting from mean position. I hope that's clear. Okay. Now we have to see graph of, like we saw energy versus time and displacement graph. We need to find other things graph also, like velocity versus displacement, velocity versus time, acceleration versus displacement, acceleration versus time. These graph also we have to see. Okay. For that, I don't know if you can see this screen or not properly. Okay. No problem, I will draw. So velocity versus displacement. Again, anyway, I will share this with you so you can see there also. Velocity versus displacement graph is like an ellipse. Okay. This is velocity versus displacement graph and velocity versus time graph. Okay. So if the object is starting from mean position velocity is maximum, it will be like this. This you can also see that V equal to A omega cos omega t. This was our formula, right? So cos theta graph we have to draw for velocity. Now acceleration versus displacement graph is like this, a straight line with a slope. Okay, acceleration versus displacement. When we go to negative side, it will be acting towards the center, and as you go to the extreme position, it will increase. And when we come to positive side also, it like maximum acceleration will be at extreme end. Okay, like that. Now acceleration versus time graph. Acceleration equation is equal to A sin omega t into omega square. So it is sine graph. So we can just, but negative sign is there, right? So negative of sine graph we have to draw. This is for acceleration. Okay. Energy graph we already discussed. I hope these four are clear for you. Displacement versus time, which will be like this, normal sine graph. D equal to A sin omega t. For this particular case, these are the graphs. Is there any doubt? Okay. Then we can move on to the next topic. Next is we are considering spring mass system. Spring mass system, we know already that F equal to minus kx. K is spring constant. Okay. Spring constant. So we already know what is omega. If you know omega, you can substitute T equal to 2 pi by omega. Omega is root k by m. So you will get T equal to 2 pi root m by k. So if you know mass of the object and spring constant, you can find time period. But problem comes when this type of combination of spring connections come. You only have to remember one thing. Combination of spring is same as combination of capacitor. Okay, you remember combination of capacitor, right? Parallel connection, series connection. It is same as that, which means parallel connection comes, K effective will be equal to K1 plus K2. Here it is series connection. Okay, series connection of capacitor, 1 by K effective equal to 1 by K1 plus 1 by K2. You only have to remember this thing. Spring combination is same as capacitor combination. Parallel connection directly adding, series connection 1 by reciprocal adding up. Okay. Please show the last slide. Okay. Okay. So same as capacitor combination. Now this one might confuse you and you might take it as series combination, but it is actually parallel combination, because if you see one end of the spring both are connected to fixed ends, okay, here and here. Other end both is connected to mass, okay. In that case it is parallel combination, okay. This is parallel combination. Series connection, one end of one spring will be connected to mass, the other one connected to the other spring, and only one end will be connected to this fixed end, okay. So series connection, this is parallel and that is also parallel. Is that clear? Do you have any doubt in this spring connection combination? Okay, so we can move on. So next is if spring is having any mass, okay. Usually we will take spring with negligible mass, but in case if spring is having any mass and that mass is equal to ms, your time period equation will change like this. So usually it will be time period equal to 2 pi root m effective by k effective. This is the formula. So combination of spring is there, you can find k effective and substitute here. If additional mass is coming and all, you can substitute total mass here. But if spring is having mass, m effective is equal to m plus ms by 3. Derivation it is not required, you only need the formula for m effective. Substitute this in place of m effective, you will get time period, okay. Is there any doubt regarding this? Repeat, okay. So equation is 2 pi root m by k, right? But in combination of spring, what happens? K might be different. So last topic also, okay. Time period is equal to 2 pi by omega, okay. So omega, for when we derived, we got it as omega equal to root k by m. Substituting it here, you will get time period of spring oscillation equal to 2 pi root m by k. Now normally it is fine, one spring one mass, it is fine, but you will get combination of spring. Combination means parallel combination or series combination, okay. Here you have to remember spring combination same as capacitor combination. Effective spring constant will be k1 plus k2 here, and in this case 1 by k effective equal to 1 by k1 plus 1 by k2 in series. Now this condition is like different, like you should not get confused, that's why I explained this one, okay. So that like both ends are connected to fixed end and other two ends are connected to m. So you can see that here also two ends connected to fixed and two connected to m. So this is parallel combination, that's what I said, okay. So since this is equal to m by k, if I am suddenly adding extra mass here, so total mass will be m plus m1 plus m2. So mass can change and here k can also change. So we modified this formula as 2 pi root m mass effective divided by k effective. Spring combination is there, find k effective, substitute it here. But spring is having mass, okay. Usually we take massless spring. In case spring is having mass, this will be effective mass which you should substitute here to find time period. Is that fine? Okay. Now coming to simple pendulum, time period equation is this, which means what is omega value? Omega is equal to root g by L. How we are getting this value? You might have thought, see, for a pendulum, simple pendulum, when you take the force acting in this direction is mg sin theta. I am not going into like how we are getting this value. You go to Newton's law, apply free body diagram, you will get. So this is the force acting on it, okay. So we can say that m a equal to minus mg sin theta, negative sign because it is acting towards mean position. Now m cancel, you will get d square theta by dt square. It will be angular motion, right? So angular acceleration equal to g minus g sin theta. Okay, sorry, there is a small mistake. It is angular motion, right? So we don't take force, we take torque. Okay, torque is equal to m into alpha. Okay, so m alpha, ml alpha, because this is the equation for torque, right? I into alpha, so m l square alpha will come. I hope I am not confusing you guys. Okay, torque equation is I alpha, we remember from rotational motion. I is moment of inertia, which is equal to mass into rotation, radius square. Radius is length of the string, so this will be equal to ml square alpha. Okay, this will be equal to force into perpendicular distance, that is equal to L, length. Okay, so here it will be minus mgl sin theta. Okay, this is how we are getting the formula. Okay, in this m cancel, square L cancel, then you will have, please send this chapter's PDF with your handwritten. Okay, I will send, no problem. Okay, now what do we have? L alpha we have, alpha equal to d square theta by dt square. I bring L to this side, so you will have minus g by L sin theta. Okay, but it is not exactly in SHM equation, right? SHM equation should be d square x by dt square equal to minus omega square x. Even if I substitute g by L as omega, what will this become? This will become d square theta by dt square equal to minus omega square sin theta. It is not sin x this side, it is just x. So here we take the assumption that theta should be very, very small. That's why when you are doing simple pendulum experiment, your physics teachers must have told you, do not do big oscillations, you should take small oscillation, because of this assumption. Theta should be very, very small. In that case, we can write it as, if theta is very, very small, sin theta approximately equal to theta. So d square theta by dt square can be written as minus omega square theta, and from here it became an equation for SHM, and here that's how we get omega equal to root g by L. Is there any doubt? Once again, here since it is a angular motion, okay, angle is changing, we take it as torque instead of force. Torque equal to I alpha. I is moment of inertia, mass into like axis of rotation square radius. So radius is length of the string, so ml square alpha will come. This side we will take torque is equal to force into perpendicular distance, right? Force is mg, perpendicular distance is L sin theta. We will substitute that also. Okay, substituting that, you will get m and m cancel on both sides, L square cancel, then we will get into this formula, because alpha is d square theta by dt square. But when we compare it with the SHM equation, it is not exactly matching. Okay, g by L we substituted as omega square also, still it is not matching. So we are taking the assumption that theta is very, very small. In that case, sin theta will be approximately equal to theta, and we can make that formula into this. This one and this one is matching, right? SHM equation. So when the angle is very small, oscillations are very small, simple pendulum is a SHM. But if you take big oscillation, simple pendulum won't be SHM. Okay, that's why when you are calculating for G, you are not getting exact correct value. Okay, because you are taking big oscillations. From this we got omega. Once we find omega, we can find a time period, because time period equal to 2 pi by omega. So every case, this is what I told you, every case we have to find what is omega. That's it. Once we find omega, we can find everything else. Is that clear? Okay. So this is the case of simple pendulum. Now coming to simple pendulum in accelerating frame. For example, in a lift or in a rocket as given in the figure. If it is in an accelerating frame, you have to add G effective. Okay. Here formula is 2 pi root L by G. We will modify it as time period equal to 2 pi root L by G effective. Means effective acceleration you have to take. If it is moving in a like rocket is moving up with acceleration AR, G effective will be equal to G plus AR. Okay, for the pendulum. If the something is coming down, lift is coming down with A acceleration, this is lift moving up with AR acceleration. Lift coming down with AR acceleration, G effective will be equal to G minus AR. Okay, so like this you have to substitute if simple pendulum is in an accelerating frame of reference. Okay, for example, lift, that is one which you will get mostly. Pseudo force, yes, it is the pseudo force. So extra acceleration will be there. Okay. Is it clear? Okay. So next is called as compound pendulum. Simple pendulum, you know, one string, at the end mass is there. Okay. Compound pendulum means the whole mass is rotating. For example, take this remote. If this is oscillating, it is a compound pendulum. Mass is not located at one end, it distributed. Okay. So such oscillations are called as compound pendulum. If you are oscillating your pen, it is also compound pendulum. It is not simple. In that case, we will just write it torque equal to I alpha. I we will not substitute, because for different objects and for different axis, I will be different. That we know from rotational motion chapter. I depend on axis of the object. So depending on axis and depending on object, since I can vary, we will not substitute that. We will just write it as I d square theta by dt square. Okay, and on RHS side, same as we took in simple pendulum, m g l sin theta. Here same only, no difference. Just that d square theta by dt square will be equal to minus mgl by I sin theta, and upon taking the assumption that theta is very small, sin theta approximately equal to theta, you will further get it as d square theta by dt square equal to minus mgl by I can write as minus omega square theta. Okay, so from this you will get omega equal to mgl by I. Therefore time period will be 2 pi root I by mgl. Previous slide. Okay, sorry I didn't see the message. Is it okay now, Kanishka? Okay. So here this is how we are getting the value of omega. Okay, don't worry, whatever, like if whenever you have to find omega on your own in any question, it won't be this complicated, it will be easy only. Okay, so don't worry about that. Is there any doubt in this? It will depend on like objects we are taking. If you are taking a ring at one point here, you have to find mr square plus mr square. Okay, 2mr square, like that you have to find I in each case. Do you have any doubt? Okay. Coming to next one, torsional pendulum. Chances of getting question from this is like very less. You won't be getting most of the time, like, but still I am just covering it. Okay, torsional pendulum, I don't know if you can see the figure or not. It is like a CD. Okay, if you take a CD and it is rotating, not like oscillating, it is rotating. Okay, that kind of oscillation is called as torsion, torsional oscillation. So CD is there, we slightly rotate it, so it will oscillate like this. Okay, that kind of oscillation is called as torsional pendulum. In such a case, when we are taking, you will get torque equal to I alpha, which is equal to minus c theta. Okay, here this c is called as torsional constant. Okay, or restoring constant, anything you can say. In this case, from like I am not going into derivation, it is same as before. You will get omega equal to c by I root and time period equal to 2 pi root I by c. Okay, this you won't get any question from that, mostly 99%, but for 1% I am giving this formula. If it is coming, you can use this formula. Is there any doubt? Okay, then we can move on. Next is superposition of SHM. Superposition of SHM happens when, like, we saw the spring, right? Like two springs are connected. Initially imagine only one spring is connected. Okay, then we suddenly attach second spring also. So at that time what happens? That is superposition of SHM. So first oscillation we are taking x1 equal to a1 sin omega t. The cases both are in same direction and having same frequency. Okay, second oscillation x2 equal to a2 sin omega t plus theta. Theta is the phase of that one. When the oscillation started, it is having some phase, that is theta. First one is having, like, it is starting from mean position, so no phase. Then resultant displacement we can find using x equal to x1 plus x2. Substituting it here, and what we are doing next is we are expanding the sin omega t, sin a plus b. Okay, this one we will open the bracket as sin a cos b plus cos a sin b. Then we will do lot of substitution in the derivation, which is not at all like needed, and we will finally get this equation. Okay, here, like, when you add two SHM and both are having same direction and frequency, then final result will be an SHM whose amplitude A will be given as this, root of a1 square plus a2 square. Is there any doubt? Okay, root of a1 square plus a2 square 2a1 a2 cos theta, and its phase phi is there, no? Here it is theta, here it is phi. Phi you can find using this formula, tan inverse a2 sin theta divided by a1 plus a2 cos theta. Using these two formulas, you can get that what is the resultant SHM. Okay. Now, if theta is equal to 0, no phase for first one, SHM are in phase and amplitude will be just A1 plus A2. And if theta is equal to pi, it will be out of phase and amplitude will be A1 minus A2. Is there any doubt? I hope there is not. So like I can change the slide, I guess. Okay. Next one, previous case, as in previous case it is in same direction but different frequency. Okay, in that case we can final displacement we can add and find, but it will not result in SHM. Okay, different frequency means it will not result in SHM. So in some questions you will get like identify which of the following is not an SHM. So sine and cos, if it is just there or multiplied is there, it will be SHM, like A sine omega t cos omega t, like in this form it is there, it will be SHM. Okay, but A sine omega 1 t plus A sine omega 2 t, different omega means it will not be in SHM. Okay, same omega it will be in SHM, different omega it will not be in SHM. Other like trigonometric function, if it is coming like tan and cot, it is not an SHM because you know the graph, it is not a repeating motion, it will go to infinity. So tan and cot coming, not SHM. Okay. Next is in perpendicular direction. Now it both were in same direction like x or y. Next is in perpendicular direction. One oscillation is, one spring is connected like this, another spring is connected like this, there is mass here and now it is oscillating, means what will be the final result. Okay, so x equal to a sin omega t, y equal to b sin omega t plus theta, like that we will take. Okay, in this also we are not going into derivation and all. If theta equal to 0, both of them starting from mean position, then y equal to plus or minus b by a x. Okay, it will be a straight line graph because straight line graph is y equal to mx plus c, just that c is equal to 0. Okay, if theta equal to 0, then it will be a straight line motion for the object. So you will get equation for y equal to plus or minus b by a x. And okay, that is case 1. Next one, case 2, theta equal to pi by 2. Okay, you just have to remember that part only. If theta equal to 0, it will be a straight line motion. Theta equal to pi by 2, then resultant you will get like this. Okay, it is a equation of ellipse. Okay, this is an equation of ellipse. If both a equal to b is given, then it will become circle. Okay, this equation for ellipse, if a equal to b, it will become circle. Is that clear? For two perpendicular SHM, when they are added, there are two cases. First case, theta equal to 0. In that case, it will be a straight line motion with equation this, y equal to plus or minus b by a x. If the phase is pi by 2, like theta is pi by 2, then in that case the resultant motion will be given by this equation. This is an equation of ellipse. Okay, it is from conic sections, like we are not randomly saying, this is the equation of an ellipse. If a equal to b, then you can write it as x square plus y square equal to a square, right? It will become like this. So this is the equation of a circle. So two cases. Is that clear? Okay. Next one is damped harmonic oscillator. Okay, this and all we don't have to go into depth. Okay, you just need to know the concept only. Damped harmonic oscillator is when we say SHM, it is ideal case. It will continue oscillation like this forever. But damped harmonic oscillator is the realistic case, because if you start swinging, you know that after some time the amplitude will decrease and you will stop. That is called as damping. Okay, once you start the oscillation, somehow the amplitude decreases and finally it becomes stop. That process is called as damping, that decreasing amplitude. Okay, and the so some resistive force is acting, right? So we will modify our force equation from minus kx to adding the resistive force also. Resistive force is dependent on velocity. So F equal to minus kx plus resistive force, that is dependent on velocity. Velocity more, force will be more, but in negative direction. So minus bv. Okay, velocity term is added and you will get our equation like this for damped harmonic oscillator. It is not simple harmonic oscillation, it is damped oscillations. Okay, in that case this will be the formula. All the other things is not required, but I just added in the slide, last slide. Okay, just give me a thumbs up if it is done means. Okay, so in damped motion you don't need any other things other than concept. It is that there will be resistive force and resistive force depends on velocity. So we add that term to the force equation and our final equation will look like this. Okay, that's it. That is damped harmonic oscillator. Coming to forced oscillation, which means by damping it will reduce, right? So you know, like somebody if you is pushing you, you can maintain the oscillation. Okay, but depends on the frequency of force. For example, see here, he is not exactly pushing the child when it is coming at the last point. At between he is pushing, so the oscillation will look different. Okay, in that case we just add the external force on this side. For damping, this side is same, this side will be 0. Forced oscillation, this side same, here it will be that external force. It should be a periodic force, therefore this cos sign is there. Okay, and here also for no further details is required, only this much. Okay, and after some time, after a long time, our original oscillation will have frequency of forced oscillation. Okay, original oscillation will have frequency of forced oscillation after a long time. Is it okay? Can we move on? Okay. Now today I haven't taken PYQs. These are practice problems. Okay, let's see if we can solve at least 5 or 6 today. PYQs you can also directly go to the site and do. That's why I took other practice problems. As you can see, which of the following expression does not represent simple harmonic motion? We just discussed that. So already in given there is a tan. I told you, if you see tan or cot, it is not simple harmonic. So this is the answer. Yes, very good. C is the answer. Okay, everybody understood? Can we move to the next question? Okay. Next one, two simple harmonic motion with same frequency act on a particle at right angles along x and y direction. If the amplitude are equal and phase difference is pi by 2, resultant motion will be. we just discussed this superposition of SHM. Like right, is it C? See, it is at right angles. Okay, right angle means superposition of perpendicular SHM, and amplitudes are equal. Amplitudes equal means A equal to B, and phase difference is pi by 2 means theta equal to pi by 2. So what will be resultant motion? Yes, somebody answered correctly, it will be a circle. I told you, if amplitudes are equal and theta is pi by 2, resultant motion circle. If like theta equal to 0, then it will be straight line motion. Okay. Okay. I hope like those who answered C understood how it is A. Circle is the answer. Is it clear for all? Okay. Next one, a simple harmonic wave having an amplitude A, time period T is represented by equation this. Okay, this is the equation of a SHM. Then value of amplitude A and period you have to find. Amplitude and period from the given equation. Given that y equal to 5 sin pi t plus 4. Okay, our general equation is, we can write in x equal to or y equal to, it's no problem. Okay, x equal to or y equal to doesn't matter. Y equal to a sin omega t plus 5. This is our general equation. On comparison we will get that amplitude equal to 5, right? Then omega, if you multiply pi inside, it will become pi t plus 4 pi. So this is our phase difference phi. This is omega t. So omega equal to pi. Okay, which means time period is equal to 2 pi by omega, which is equal to 2 seconds. So answer is option D. Is that clear for all? Okay. So we can move to the next question then. Next one. The amplitude of a particle executing SHM is 4 centimeter. So amplitude equal to 4 centimeter. At the mean position, the speed of the particle is 16 centimeter. So velocity at mean equal to 16 centimeter per second. Distance of particle from mean position at which speed of the particle becomes 8√3. So speed is equal to 8√3 centimeter per second. You have to find the position at which the velocity is this. Okay. Now velocity equation is equal to omega root a square minus x square. Okay, I can substitute it here. Okay, so 8√3 equal to omega root of a square minus x square. A is given, omega we don't know, right? But another one is given. So at mean position velocity is equal to omega a, because x is equal to 0. From this you can find omega equal to v mean divided by a. Substitute that here and solve. Okay, already got the answer. 2 centimeter, correct. I hope everybody understood the steps. Now from omega substitute it here. So you will get omega square into a square minus x square equal to 64 into 3. Substitute other values and cross multiply. You can solve for x from this. Did everybody get option D answer? Okay, then we can move to the next question. Next one, a body executes simple harmonic motion, have amplitude A, potential energy P, kinetic energy K, total energy T. Which are measured as function of displacement? Which of the following statement is true? You have to find true statement in among this. See, total energy is 0. That we can cancel that time itself, because total energy is constant and always half Ka square. Potential energy is maximum when x equal to 0. At x equal to P equal to half Kx square. X equal to 0, potential energy minimum. So this is also not true. Among the other, kinetic energy is maximum when x equal to A. At extreme position, velocity is 0. Kinetic energy will be 0 there. So this is also wrong, then this is true. Like, you don't have to calculate it even by eliminating other options. Naturally this will become the correct one. But even if you substitute by putting x equal to A by root 2, you will get the correct answer only. Is that clear for all? Okay. So next question. Total energy of a particle executing SHM is 80 joules. What is the potential energy when particle is at a distance of 3 by 4 of amplitude from the mean position? So x is equal to 3 by 4 A. Okay. So total energy is given as 80 joule. Okay. Now, like you have to find energy at this position, right? Potential energy. Potential energy is equal to half K x square. X is given but K is not there. So that's why we substitute this equal to half K A square. Total energy equation. Okay. Somebody already got the answer. Good. But let's see is that the answer or not. Okay. So from this we can find K equal to 2 into 80 divided by A square. Okay. Substituting it here, you will have half 2 into 80 divided by A square into 9 by 16 A square. A square will get cancelled. Calculate the rest. See, two cancel here. 16 to 80 10. So 2 10 5 into 9 equal to 45 joule. D is the answer. Okay. Yes, D is the answer. So please, like, you have to speed up your calculation. That is true because you have less time here, but make sure that you are not making mistakes. So while practicing, please write down every step, every value, then calculate. Okay. Next question. Graph of the square of velocity against square of acceleration. So this is V square A square graph. We can find a relation between them. Okay. V square will be equal to omega square A square minus x square. A square is equal to it is omega square x, so omega square x square into omega square. This will be acceleration square. Why I wrote like this is because if I take it inside, I will get a square omega square minus omega square x square. So omega square x square I can substitute as v square equal to a square omega square minus acceleration square divided by omega square. Okay, as we already know, a's amplitude is constant, omega is constant, so this will be c, a square omega square, minus 1 by omega square will be a constant value, so let's write it as m, so m a square. This is similar to, if I substitute v square equal to y, y equal to m, a square equal to x, minus mx plus c. Okay, it is just an equation for straight line. Screen is not visible. Okay, is it same for everybody? Screen not visible? I didn't understand the meaning of thumbs down. Is it visible or not? Somebody like unmute and say, okay, it's not visible. What about now? Okay. Okay, I just substituted a square in and combined a square and v square together. On comparison, I will get that y equal to minus mx plus c, same equation. It's an equation for straight line. So a and b is not the answer. Among c and d, which will be, here it is negative slope, minus m. So option D, negative slope. Okay, is that clear for all? Okay, then we can move to the next question. Next one, a mass m is suspended from a spring of negligible mass. Spring is pulled a little and released so that mass execute a SHM of time period t. Mass is increased by m, then the time period becomes 5t by 3, ratio of m by m. Okay, initially m mass is there, t time period. So, and for spring t equal to 2 pi root m by k. Next case, for t dash is equal to 2 pi root mass is changed. So, m plus small m will come, divided by k did not change, so k. Okay, t dash is given as 5t by 3. You have to find the ratio of m by m, right? So t dash by t we will do. So 5 by 3 equal to under root of m plus m by m. Okay, on squaring you will get 25 by 9 equal to 1 plus m by m. So m by m equal to 25 by 9 minus 1. Answer 2 pi. 2 pi will get cancelled. We are taking the ratio, right? Like we are doing t dash divided by t. Okay, so t dash equal to 5 by 3t by t cancel, then 2 pi root m plus m by k divided by 2 pi root m by k. So 2 pi cancel. Okay, yes, option C is the answer. Good. Last question, one more question we can do, then we will stop for today. Okay, next one, a simple pendulum performs SHM about x equal to 0 with an amplitude a and time period t. What is the speed of pendulum at, this is an easy one, so we will do one more question. Speed of pendulum at x equal to a by 2. Surabhi, is it for this one? Speed is equal to omega root a square minus x square. Omega is not given, but time period is given. So omega is equal to 2 pi by t. Okay, 2 pi by t will come. Okay, substituting that here, v equal to 2 pi by t root of a square minus x equal to, okay, a square by 4. Yes, option A is the answer. Is this clear for all? Okay. So we will do this one also. Okay, graph question. So we can stop after this. So given particle executing SHM, displacement x is given by x equal to a cos omega t. Identify the graph which represent variation of potential energy as a function of time t and displacement x. So this is potential energy versus time. This is potential energy versus x. Okay, for x it is not going to change, because when x is 0, potential energy is minimum and it is U shape only. So that is 3. Okay, one option we got, it is 3. Now here it is 1 or 2 that we need to find. Okay, it is not B, sorry. Okay, now coming to potential energy as a function of time. Here it is given as A equal to A cos omega t. So when t equal to 0, cos 0 is 1. So when t equal to 0, particle is at extreme position. Extreme position, potential energy is maximum. Okay, so it will start from when t equal to 0, potential energy is maximum. So it will start from top. So option 1 and 3 is the answer, A. I hope that's clear for you. It is because x equal to a cos omega t. If x equal to a sin omega t, then it will start from 0. But since x is equal to a cos omega t, when t equal to 0, x is equal to a. T equal to 0, x equal to a, which means potential energy equal to half k x square will be a square. It will be maximum at t equal to 0. So it will start from maximum point. Okay. So I think we can stop our class here. I hope everybody understood. Some more questions are there in the slide. Please practice them. And if you have any doubt regarding those questions, contact me. My number is in the group. Okay. Explain again. One more question. Oh my god. Here potential energy versus displacement, it will always be U. You don't have to worry about that. So easily we can take. But potential energy versus time, if you are taking, then you have to consider this. See that like at x equal to t equal to 0, what will be value of x? When t equal to 0, cos 0 is 1, x equal to a. In that case, potential energy equation is half kx square, right? If I substitute x equal to a, potential energy becomes half ka square. So when t equal to 0, potential energy is maximum value. So at t 0, potential energy maximum. So it will start from top. Okay, that is the graph. I hope you understood. Kanishka? Okay. If you want, okay. If you want one more question, I can do this. We can. A spring balance has a scale that reads from. Okay, this is a very good question. Thanks for suggesting one more. Okay. So a spring balance has a scale that reads from 0 to 50 kg. Length of the scale is 20 centimeter. Body suspended from this balance when displaced and released oscillate with a period of 0.6. What is the weight of the body? For spring, we know that time period is equal to 2 pi root m by k. Time period is given, we have to find m. So which is not given? K is not given. Okay, but other some details are given. No, from that you can find k, that is 450 kg. Okay, it can vary from 0 to 50, means at 50 kg it will have maximum extension. Maximum extension is 20 centimeter. X is equal to 20 centimeter. So mg, force, equal to kx. Just substitute. X equal to 20. mg 50 into 10, or like better take 9.8. Okay, in this question take 9.8. 50 into 9.8 is force, equal to k into 20 into 10 to the power minus 2 centimeter. From this you can get the value of k, substitute it here and find m. This is the step. Is that clear for all? I am not going into calculation, there is no time. You will get the answer A. Take G as 9.8 in this. Okay. If this is done, you guys can leave. Thank you for attending the class. See you